So I'll start. Aishwarya, I can start.
Yes, sir.
Yeah, okay.
Yeah, there is an opportunity in every adversity, says great stalwarts. Yes, our webinar is a creation of this challenging year of pandemic. Good morning, friends. On behalf of QCrete Readymix India Private Limited, I welcome all registered delegates to our QCrete webinar series number 21. This webinar is conducted in association with Dr. Fixit Institute of Structural Protection and Rehabilitations, Mumbai. Let me take this opportunity to welcome our renowned speaker, Engineer Mr. E. Gopal Krishnan, who has kindly consented to take today's session on non-destructive evaluation of reinforced concrete structures, application of non-destructive testing. A versatile expert in the field of civil engineering, he has adorned many positions during his illustrious career. So he needs no introduction, but let me brief you about his credentials. E. Gopal Krishnan, civil engineer working as head of advanced diagnostic and rehabilitations, which is promoted by Pidilite Industries Limited. He is having 30 years of rich experience in construction field involved in infrastructure projects. He has established advanced diagnostic laboratory of Dr. Fixit Institute of Structural Protection and Rehabilitation, Mumbai, which is Enable accredited. He is an empaneled lead auditor as per ISO 17025. He has authored several papers and delivered technical lectures, and especially for NICMAR. A hearty welcome to you, sir. We indeed delighted for your coming forward to present your present the topic. Once more, a hearty welcome to all our August virtual audience for our webinar series. Definitely, you will have a fruitful day today. Thank you. Thank you very much. Yes.
Thank you, Mr. Shalif Fernandez. Good morning, all of you. Let's have a good applause for all the participants taken out time from your schedule and want to hear something on the engineering aspect. Whatever we build, we need to assure sometimes. To understanding this, we will be talking about a lot of assessment techniques using different non-destructive testing, and what will be getting benefited through this. Let me introduce my organization where I belongs to. I belongs to Dr. Fixit Institute of Structural Protection and Rehabilitation. That is a not-for-profit company. It's registered under Section 25 Act of 1956. The vision of this creation of the institute is to become the primary knowledge center for the skill development, also involved in the repair and waterproofing and area of renewable engineering. That is the vision of this creation of this institute under the Pidilite Industries. The mission is we offer advisory services in structural repair related to other engineering aspects, renewal of engineering, restoration and waterproofing, distress assessment of concrete structures with a state-of-the-art advanced diagnostic laboratory facilities. We are providing third-party services to all the industries invariably. That is the brief background. We are associated with Concrete Institute of Australia, New York Roofing Contractor Association of USA, and the Concrete Society UK, International Concrete Repair Institute of USA. With the association with them, we update our knowledge, we exchange our latest technology developed in those countries. We are adopting some of them. We also exchange the expertise. We invite the special lectures or providing solution for a project based or related to the assessment of the structures and the strengthening of the structures. We are exchanging the ideas with all the institutions. And whatever we are going to talk about, what are the services we are giving to the industry? One is we conduct the structural audit, which means we conduct the comprehensive audit and provide the recommendation with rate analysis, so that they can able to take care of the repair part for rehabilitation of the structure purpose. Second one, we conduct a non-destructive testing as well as partially destructive testing in advanced level, that I am going to cover today. What are the testing and what are the informations about those. And the third part, we conduct a petrography examination under the microscopic lab to understand you're all there, related to the concrete somehow. When you are making a concrete, you want to ensure that your aggregate is not a alkali aggregate reactivity is creating a problem later stages, or it's a reactive aggregate should not be used in the concrete. Try to find out as per IS 2386, we conduct this petrography. We are conducting for across the country, we are helping them. And the next point is we conduct a thermography survey, to diagnose the building diagnosis, to find out that, the source of dampness or leakages, and provide the solution using this technique. I'm having one of the beautiful case study today to explain you on this also. Then whatever the services we are offering, it is all accredited under National Accreditation Board of Testing and Calibration of Laboratories, which means we have accredited mechanical, like related to concrete testing, non-destructive testing, chemical testing as per the standard. Once we issue the certificate, it's valid not only in the country, it's valid across the globe, because this international standard is accepted by and large majority of the countries. Then we also provide a proficiency testing provider for mechanical and NDT. Those who are interested to get it accreditation from accreditation body, we are helping them to provide these services. They can compare the result with many other laboratories, and we are certifying them, whether you are satisfactory or you are having a doubtful or you are not satisfactory. So that kind of evaluation we carried out, whether it's in a non-destructive testings or concrete related, and certify the lab competency. For that also we have accredited, we are authorized. So this is one of the photograph when the participants come to our institute to participate. Okay, this is a brief introduction. Let me start what we'll be discussing today. Today we will be discussing what is service life, why non-destructive evaluation, different step of condition assessment, non-destructive testing techniques, and case studies. This is what we want to cover today. Just for setting up the context, let me start some of the news which is appeared in the newspaper recently. When I stay in Mumbai, I more relevant to talk about Mumbai. So Mumbai makes structural audit of 30-year-old buildings mandatory. You people may be hearing the news or newspaper stating that in Bombay, building collapsed oftenly during the monsoon, especially. Why? Because there is a lot of related to the durability issue or the design related issue, or it's not withstand with the severe exposure condition because it deteriorates too early. So these are all the reasons. What we say is that the municipal corporation has made a mandatory. Every building has to go this kind of audit after 30 years old of building. Mandatory to check every now and then. The frequency set by them 3 years. Once in a 3 years, after 30 years, you have to keep doing and submitting the report to BMC. But what's happening? There are so many buildings or get the BMC notice for structural audit, like 1.59 lakhs buildings. But what's happening? Nobody follows. By and large, it is ignored, largely ignored. Result in that we are having the disasters. If the scenario is in Mumbai like that, what about Delhi? In Delhi, South Delhi Municipal Corporation asked for a structural audit report for the high-risk buildings, school and housing societies, and other, the common buildings, which is not even 20 years old. This is one example. The Sun Valley Society as constructed in 2003, it has deteriorated so much. Now what's happening? They are strengthening the columns, beams, okay, which was reinforcement exposed already. What could be the reason? Whether it is a design failure or the quality of the material used for construction or the workmanship. Either one of them could be the reason for that. In the 17 years building getting deteriorated, they start strengthening now. So what will be the life of the structures? Big question. So for that, we must understand the service life. For longer time, we thought that concrete was considered to be very durable material and required little maintenance or no maintenance. However, many structures around the world has shown deterioration during the last 60 to 70 years. But in this case, whatever I shown in the previous slide is not in 70, not even 17 years old structures. It got deteriorations because the exposure condition also have been found to play vital role for the durability of the concrete. When you're talking about the service life, as per IS 456, durable concrete is one that performs satisfactorily in the working environment during the anticipated exposure conditions and during its service life. That is the definition given as per IS 456. Here, what are the parameters affecting the durability or service life? The carbonation, chloride ingress, alkali silica reaction, freezing thaw action. But there is not a concern in the majority part of India. We don't have that climate. So based on the exposure conditions, structures deteriorate. Different structures having different service life, but most of the structures do not attain their service life because of poor maintenance. Okay, so based on the corrosion, chemical attack, alkali silicate reactivity, or delayed etching formation. These are the one of the issues of affecting the durability factor. Then multiple transport mechanism involved. When the concrete is exposed to the different exposure condition, there will be a cracking, hazardous gases and moisture enter to make the structure is weak. What are the process it's going to be? And again, the selection of material and mix design criteria, the quality of the material. Then we check the cube samples to ensure that whether this particular member has received the required strength, but we never do the specimen or the structure for the durability aspect. We only the part of the sample we check in the laboratory, which is controlled conditions. So nowadays everybody talking about performance-based durability aspects. Okay, so the various parameter for a durable concrete is design detail, good construction practice, the chloride, sulfate, carbon dioxide, other potential deterioration substance entering to the structures, and impermeability is a greatly governed to the constitution's workmanship in making concrete. Okay, the various parameters of the durable concrete is design detail, good construction quality, I said, compaction, cover, curing, and proper mix proportions with having a low water cement ratio, and the quality of the cementitious material such as pulverized fly ash, silica fume, and chemical admixtures, etc. These are all the things makes durable concrete. This definitely going to be the high performance concrete. But in spite of all our precautions, preventions, the concrete deteriorates in severe and extremely severe exposure conditions. So the root cause of deterioration need to be ascertained. So understanding the schematic stages of corrosion-induced deterioration of the concrete structures, this slide you can able to see there are the 4 stages mentioned in this figure. The first one is the depassivation of the steel reinforcement due to the external environmental influence. At this point, corrosion is possible, but there is no observable or actual physical damage you can see at the surface. When you go to the stage 2, the development of corrosion, which occupying the volume significantly larger than the original steel. Normally, the corrosion of steel bars occupy volume of 3 to 6 times that of original steel. This induced tension in the concrete covers lead to be cracking. So, number 3 stage, the widening the crack facilitate the penetration of moisture and aggressive substance into the concrete, promoting a faster rate of corrosion, eventually leading into the spalling of area. You can able to see the stage 3. The stage 4, the corrosion progress at an increased rate, resulting in more cracking and spalling of concrete cover and increasing loss of cross-sectional area at the embedded steel reinforcement. This lead to significant reduction in the strength of affected member, which may eventually lead to their collapse. So, which is shown in the stage 4. This situation, the propagation phase, required urgent intervention. The initial phase, if you see, there is no appreciable amount of defects or damage. Once it reaches to the propagation stage, the rate of deterioration increases. This leads to severe damage of the structures. Hence, the use of NDT is quite useful here in this propagation phase. So let me play one audio visual to understand the process of corrosion.
Corrosion can be described as a process or chemical reaction where refined metals such as steel and iron return to their more stable combined forms as oxides, carbonates, or sulfides. In this chemical reaction,
light is not moving.
Material acts as
light is not moving.
It's not moving.
No, electrons.
Yeah, you have to bear with me. There is a couple of minutes. The delay will be there. Couple of minutes. The delay will be there.
It is in the first slide only. Now? Yeah, it is in the first slide only now. It is in the first slide only. It's standing in the first slide.
Okay, okay. I see. Just a minute. I will. I can view one. Now you can see.
No, sir.
Corrosion can be described.
No. Which slide you are talking about? The very beginning?
No, sir.
It is there in the beginning only.
Yes, sir. From the beginning, it is there from the beginning.
In the beginning only.
You can see this one. You can see this one durability slide.
No, nothing. Not yet moved.
Sir, now you can share again.
You're not seeing. Okay. Just a minute.
Okay.
You can able to see now?
Yes, sir. We can see only the first slide.
Next one.
Yes, sir. Now it is moving.
Okay, okay. So you mean to say I have to cover from all the things?
Yes.
Okay, fine. Because I didn't know that because nobody has told me. Okay, fine. See, just bear with me. I have to start from the beginning once again. So maybe another 5 minutes I will take, if it is okay.
No problem, sir.
Yeah. Okay.
Just in the introduction, I was talking about, I come from that Dr. Fixit Institute of Structural Protection Rehabilitation, which is not for a profit company, registered under Section 25 of Indian Companies Act. And our vision is to become the premier knowledge center in the skill development or repair or waterproofing, other area of renewable engineering. That was our mission. So we offer advisory services in structural repair, restoration, and waterproofing and distress assessment of concrete structures with a state-of-the-art advanced diagnostic facilities, which is created under the Dr. Fixit Institute of Structural Protection Rehabilitation. Now, I was mentioning about that we are in association with a different international network. One is Concrete Institute of Australia and the New York Roofing Contractor Association of USA, Concrete Society of UK, International Concrete Repair Institute of USA. We exchange our views, ideas, and latest technique developed in those countries. We adopt, we practice here. Even we exchange our expertise. We invite them, especially to handle the project or delivering a technical lectures and so on. We had been collaborating this international network, including the national. The services I discussed already, I can go quickly once again. We conduct a structural audit, comprehensive structural audit of the buildings by using the non-destructive testing methods. Based on that, we provide the repair scheme with a rate analysis so that the customer can preciously, budget for repair and execution for the repair without wasting much money on this. Second one, we provide a non-destructive testing services to various organizations, consultant, other those who are in the structural engineering field. We provide those services. Some of the advanced non-destructive testing, which I am going to discuss today in our presentation, this also we are offering to the organizations, those who want to avail the services from us. The next part, we conduct a petrography examination where we can see the type of quality of the aggregate, type of rock, what is the mineralogy, whether we can suitable, it may be used for a suitable making concrete. We can check through the petrography. This technique is important as per IS 2386. There is a requirement to conduct the petrography examination before we source it out for making a concrete. Nowadays, this RMC association, they are regularly conducting the test from us because this is a mandatory requirement for them to get it tested, petrography examination, before start using any quarry or new source of materials. Then thermography survey, we generally use for building diagnosis, mainly for the identification of the seepage or dampness, what is the source, how to rectify. This information we get from the thermography surveys. Now I am audible and slide is clear. Can anybody can confirm to me?
Yes, sir. Yes, sir.
It is clear. It is clear. You can carry on. No,
fine. Very good. And I was telling that we had been accredited, National Accreditation Board of Testing and Calibration Laboratories for our all the mechanical testing, concrete related and non-destructive testings, chemical test. Once we issue the certificate with this kind of NABL symbol or the International Laboratory Cooperation, Accreditation Cooperation symbol, which is not only valid in the country, it's valid across the globe. Our certificate is recognized having this accreditation. So our work is genuine. We have got an authentication of that. Similarly, we also provide a service to those who want to get accreditation. We provide a proficiency testing services. They will come to us, they will participate in our program. We certify them. Yes, you are a competent person, your lab is competent. You can, your results are satisfactory, or it is not satisfactory. Like that, we give the competency certificate to the laboratories, those who are into the material testing, NDT testing, for getting their accreditation from National Accreditation Body. This is one of the photograph we have taken during the one of the program. The people come to our institute, they participate. There are a lot of people. One is a National Test House and National Council of Cement and Building Materials. Like many people, they'll come to us beside other third-party labs. Okay, we certify them. For that also, we have got accreditation. This is a basic introduction of my organization background. Now, what we'll be discussing today, one is that service life, why non-destructive evaluation is required, different step of condition assessment, non-destructive testing techniques, and case studies, which will be making you interesting for the listening today's topic. Let us start understanding about the background. In Mumbai, there is a municipal corporation. They are making structural audit of for 30 years old buildings are mandatory. They're saying that building which is older than 30 years, they have to go for a structural audit more frequently. The frequency is set by them once in 3 years. They have to conduct the audit, submit the report to BMC, and they have to do the maintenance accordingly. For that, the by law they issued a notice. They issued so many notice to housing societies in the past. In the last year, they issued 1.59 lakhs buildings to get BMC notice for structural audit. This is a situation. But if you ask me 1.59 lakhs, whether they get audited, what happened next? Nothing happened. Largely, people are ignored. The few of them taken serious, they do it meticulously, but rest of them just ignore this. That is the reason we keep hearing that the building collapse here and there. Particularly in Mumbai, I keep observing every monsoon there is a one or two buildings, having this fact. So this year also already two incidents happened so far during this monsoon. What about Delhi? Even South Delhi Municipal Corporation has structural audit report from high-raised buildings, schools, and housing societies. So the building is constructed only in 2003. Now even 17 years they have not completed. Still it deteriorates. They have started working strengthening of column beams, and they are doing the reinforcement repair, which is already got exposed. What you can say, because of the severe exposure condition or quality of the material or workmanship? Now I will leave it to you. You can guess what could be the reason for this early deterioration happened to this building, which is in Delhi. Similarly, I assure you that you can also see your neighbors, your place. What will be the situation? What is the factors affecting the service life or durability of the structures? When you talk about service life, the most of the times what we think, the concrete was considered to be a very durable material, required little or no maintenance. However, many structures around the world have shown the deterioration during the last 60 to 70 years, because the exposure conditions have been found play a vital role for the durability of concrete. If you see, as per IS 456, the durable concrete is one of the perform satisfactorily in the working environment during the anticipated exposure conditions and during its service life. So, based on the exposure condition, the structure deteriorates. Different structures are having different service life, but most of the structures do not attain their service life because of the poor maintenance. This can be, major parameters like carbonation, chloride increase, alkali silica reaction, and freeze and thaw action. However, which is not common in our country. This may be applicable to the European countries or cold region countries. The durability main issue is the corrosion of the river. Corrosion is affecting the durability of the structure. Second one is the chemical attack, ingress of chloride, sulfate. This affects the durability of the structures. Then alkali silica reactivity, delayed ethylene formation. This is all the primary issue. And secondly, if we talk about the multiple transport mechanism, which is hazardous gases and moisture entering into the concrete element, the members, to have starting the corrosion. Okay, and one step before, we can say the selection of raw material quality and mixation criteria. Okay, you are all familiar with the mixation. I'm not going to discuss about the mixation, but of course, what are the parameters we discuss? A durable concrete design, what to be, followed, and what are the good construction practices like compaction, cover, curing, proper mix proportions, lower water cement ratio, and using cementitious materials such as pulverized flash, silica fume, and chemical admixtures. And durable concrete always should have the high performance concrete. So the material and process both are very, very important. But in spite of all our precautions and preventions, concrete deteriorates in severe and extremely severe exposure conditions. So the root cause of deterioration need to be ascertained. How we are going to ascertain the root cause? Just one of the slide I want to explain to you how the schematic stage of corrosion-induced deterioration of concrete structures. Okay, here the stages mentioned in the figure as shown 4 stages. One is the initial phase. In the second phase is a propagation phase. In the first one, we can say depassivation of the steel reinforcement. It's happening because of the environmental influences. At this point, the corrosion is possible, but there is no observable or actual physical damage you can absorb. If you go to the second stage of propagation phase, the development of corrosion, which occupying the volume of steel significantly larger than its original. Generally, we say 3 to 6.5 times of the original steel. The process of increasing the volume of the steel. The corrosion of steel bars occupy the volume 3 to 6 times that from the original steel here. Okay. Then the third stage, the crack is widening. It facilitates the penetration of moisture and aggressive substances into the concrete, promoting a faster rate of corrosion, eventually leading to the spalling of cover of concrete. The cover is fallen. You can see that. The corrosion progresses at the increased rate in the stage 4, resulting in more cracking, spalling of concrete cover, and increasing loss of cross-sectional area of the embedded steel reinforcement. Then what happened? This lead to a significant reduction in the strength of the affected member, which may eventually lead to their collapse. This situation required urgent intervention. This propagation phase required urgent intervention to set it right. In the initial phases, there is no appreciable amount of defects or damage. Once it reaches to the propagation stage, the rate of corrosion increases. This leads to the severe damage to the structures. So we need to diagnose the reason, whether it's happening because of the corrosion, because of the material deterioration, or any other parameters. So for that, we required a diagnosis of the structures or assessment of the structures by using various non-destructive testing techniques. Let me run the video. It will take a couple of minutes delay. You have to just give few seconds to watch. Please, anyone is confirm that whether you can able to see the screen now.
Screen is visible.
Corrosion can be described as a process or chemical reaction
Can you hear audio
where
as well?
refined metals such as steel and iron return to their more stable combined forms as oxides, carbonates, or sulfides. In this chemical reaction, a section of the steel material acts as an anode. This means that the steel loses electrons. On the other hand, another portion of the reinforcing mesh acts as a cathode. In the cathode, oxygen combines with water and the electrons to release hydroxide ions. This shows that the reactions require both water and oxygen to occur. The volume of corrosion products, especially Fe2O3, is significantly higher than the original steel. This will increase the internal pressure and consequently crack the concrete. We know that the availability of these 3 elements are essential for corrosion to happen. The reaction requires water and oxygen. However, experiments in real case scenarios show that chloride plays a key role in the onset of corrosion. Concrete provides a high alkalinity environment around the reinforcement. In normal conditions, one can expect this will protect the reinforcing bars from corrosion. At the same time, we know that concrete is a permeable material, as moisture and aggressive ions can move through the pore structure of concrete. The interesting question that arises here is the role of chloride ion in this reaction. This has been the topic of research for many corrosion specialists around the world, yet there is no definite answer to it. A very basic explanation is that the ingress of chloride destroys the protective oxide layer on the surface of rebar. This eventually destabilizes the protective film over the reinforcement, which eventually leads to the initiation of corrosion. As I mentioned earlier in this presentation, the porosity of concrete makes it possible for ions to penetrate into concrete and make the concrete itself act as an electrolyte. Corrosion happens in this environment, and the movement of electrons in concrete creates an electrical potential field inside concrete over the surface of rebar. For example, the reactions in the anode, where steel loses electrons, can create a potential difference of negative 780 millivolts compared to a standard copper sulfate electrode. The cathodic reactions would result in a potential difference of positive 160 millivolts. The traditional way of investigating corrosion is visual inspection. However, when damage is detected in visual inspection, it is already too late. Signs of corrosion are often marked with delamination, which is the result of corrosion materials expanding. Visual inspection is often performed with chain dragging tests to identify the delaminated areas. At this stage, there is not much left to do except repair. Corrosion activity is often a corrosion study. The first concept is the half-cell potential. In this method, surface potential measurement is used to predict the probability of corrosion. While the test provides useful information about the chance of corrosion for the area under investigation, the results can easily become misleading if the potential effect of influencing parameters are not appropriately taken into account. Another limitation of the test is that it does not provide any information about the kinetics of corrosion reactions. The second concept is the rate of steel corrosion. The corrosion rate is about the kinetics of reaction and how fast the corrosion is progressing in the concrete. This becomes important in the context of life cycle assessment, as it helps engineers better predict the remaining service life of a given structure. So let's talk a little about these concepts and measurement test methods. The half-cell test can be used to predict the corrosion potential from the surface of concrete. Several associations have standardized the test procedure, including ASTM, UNI, and RILM. In the half-cell potential method, the potential values at the surface of concrete are measured with respect to a reference point. Concrete surface should be prepared before doing the test, that is to remove paint or other non-conductive layers from the surface. The surface should have a minimum amount of moisture. A sound electrical connection should be established between the reference electrode and reinforcement. The value is normally presented in contour plots, showing different half-cell potential values. This helps identify areas with a higher chance of corrosion. For example, ASTM C876 introduces 3 different ranges for the measurement. Half-cell potential values less than negative 350 millivolts, measured in reference to copper sulfate electrode, represent an area where probability of having active corrosion is more than 90%. One measurement is higher than negative 200 millivolts. This probability is less than 10%. Results for half-cell potential values between negative 200 millivolts to negative 350 millivolts is uncertain. Corrosion can be described.
So, understanding the corrosion, we move to the structural assessment. This diagram shows here how the structural distress is assessed. One is that the one must have the knowledge on the structural distress analysis. Then only you can able to complete this aspect. Understanding the distress, we try to understand through the visual inspection what is the cracking, what is the deflection of the member, vibrations, spalling, or fire damaged members, etc. Then we use the non-destructive testings and understanding how we get the information about the corrosion or chloride ingress or corrosion related issues and other distress. Once we diagnose this, and we will use the extensive non-destructive testings and get the results. Based on that, we provide the recommendation and remedial measures, what need to be repaired, or we need to do the rehabilitation of the structures. What are the structural elements, non-structural elements, where we want to have a strengthening, where we want to have a strengthening the non-structural members, or what is the replacement of the structural members required. So we will be able to categorically create that severity based on the approach, which one need to be given a more attention, immediate attention, or a very casual approach. So we can able to do the categorize. This will help structural assessment. There are different type of assessment. One is strength assessment, assessing the strength of the concrete. Second one, durability assessment, to identifying the distress or extent of distress. or suspected deterioration, including the corrosion activity of reinforcement. We understand this and we predict the residual service life of the structures, which is called durability assessment. The third one is integrity assessment. How to determining the localized integrity or as a behavior of old structures, generalized assessment of behavior of old structures. So these three type of assessment we conduct regularly. What is the reason for structural testing? For understanding the strength, to carry out a comparative quality survey, which is called condition survey of the particular building or structures, or to examine the localized integrity, where there is any problem on the localized problems, or to assess the potential durability. Okay, to identify the causes and extend the deterioration, we understand and do the structural testing. In this one, what is the process we adopt? We establish aim of the assessment and the information required we need to collect, which is called preliminary investigation, which is we can study the documents, review the records, and we conduct the rapid visual inspection initially for planning of conducting the detailed survey, which is called the initial diagnosis. This is called preliminary investigation informations. This will give the planning for a detailed investigation. This is stage 1, and this is the initial phase we can call it. And going to the next level, detailed investigation. Based on the initial investigation, we can decide what is the test to be conducted, what is the number, because it's always on the sampling principle. We cannot do 100%. Some of the tests we conduct in situ testing, and some of them we send it to the laboratory to understand the strength of the core, understanding the chemical properties of the concrete samples we do at laboratory, and based on that we study that and see the adequacy of the structures based on the calculations. Based on those results, we evaluate those results, we do the interpretation, and we give the final findings. Based on that, we give the recommendation for proposal methodology of the repair. Okay. Once we complete, this is a complete assessment of second stage. This is called detailed phase of assessment. These two stages are necessary for assessing any structures. If you want to simplify, I can tell you the first step, we do the visual inspection and do the NDT on second, and group of NDT tests. In the NDT test, always I tell that it's not a one NDT test, we can get the value and based on that we can interpret. We have to conduct group of NDT tests, each test complement each other to give the better understanding of the particular structures. And some of the tests may be the destructive test. And another step is the laboratory test, where we can analyze the sample, whether it's a petrography examination or the chemical examinations, and the interpretation of the result. Then we'll move to the recommendation based on the findings. Finally, we estimate the cost of the repair. Budgeting is very, very important. We cannot ignore. When budget is not there, how the repair can happen. So we need to have the estimation of the cost. This is all the sequence of conducting the assessment of the structures and planning for a repair and rehabilitation. Okay. Now coming to the non-destructive testing. Non-destructive testing, it itself says that it's a group of analysis technique. We can inspect or measure without damaging the structures. That is the non-destructive testing. Very basic non-destructive testing is using the sounding method. We can use a hammer to find out whether it's any hollow sound is there or not. When delamination is there, you can able to mark out that area, the delamination causing because of the corrosion or any other reasons we can able to find out. It may be honeycomb area or maybe the corrosion related one we can see here in this picture, because it's coming the separation above the reinforcement. I explained to the deterioration mechanism in the previous slide, that's why this delamination happening. Okay. And the second one, by larger areas you can use the chain dragging method to understand this hollowness or delamination areas. So these all the visual examination we conduct. Further moving to, we started using non-destructive testing and principles. So we use a non-destructive test to test the integrity of the material or structure for the health assessment. Okay, this is basically the mechanical properties. When you want to the strength of the concrete, we do the destructive methods, coring, pull-out test. And when you say the non-destructive testing method, the Smith-Hammer test or ultrasonic pulse velocity we use. The rebound hammer test, you all know, sir, is measure the rebound of spring-driven mass after impact with a rod in contact with the concrete. Okay, this is a very simple and the very familiar method. Everybody is aware of the things because I am talking a very basic things. It's always, it will be the, to understand the estimation of the play strength if the correlation is developed with the rebound hammer numbers. So how the operates is, we have to push and release the rod, and we can able to read the readings in a log question, which is shown here. I will explain to you. Okay. Now how the operation is taking place, because of the spring action, we can get a high impact value when the surface is hot, and the low impact value surface is smooth or high porosity. That is the way it gives the results. Now we can see that in the sliding there, you can see the rebound number is given. This is the mechanical hammer. Now, how to correlate the strength? There are charts and tables provided with the instrument that should not be used for absolute estimation of the compressive strength. We can take it as an indicative. But better relation, you need to create your own. We understand the strength and elastic modulus of concrete near to surface. It affects based on the type of aggregate dependence and thickness of the carbonation zone, because 50% higher value can achieve because of the carbonated concrete, and the surface structure. If it is a rough, definitely we have to make it smooth to get the proper readings. It will affect if its surface is rough, and moisture conditions affect the results, and the rigidity of the test object also affect the rebound numbers. Now, traditionally, the rebound numbers increasingly has an angle variation from vertical down to vertical up. There is a correction factor, already mentioned that as you shown in the figure. There is a different angle, so you can see the same location. What is the difference in the rebound numbers? So when is the stronger portion, you can get the higher rebound numbers. The weaker portion, because it's a low rebound numbers. This is a principle, the amount of intention is taking place. So generally we take the average of 6 readings as a rebound index. Okay, this affects because of the hitting the aggregate or air pockets or rough surfaces or dry or carbonation surface. These all the factors affecting the results significantly. Now just I can show the video for better understanding.
In this video, we'll be covering a quick review of the rebound hammer testing method. Since its introduction in 1948, the rebound hammer has become extremely popular, mainly for its simplicity and ease of use. It is an inexpensive and quick method for non-destructive testing evaluation of concrete hardness. The main applications for the rebound hammer are to assess the in-place uniformity of concrete and to estimate the in-place strength of concrete if a correlation is developed. In order to test, the plunger is pushed against the concrete perpendicular to the surface. As the hammer body is pushed towards the concrete, the force causes the latch to release and make an impact on the concrete. Essentially, the rebound of the spring-driven mass is measured after its impact with concrete surfaces. The output of the rebound hammer is then referred to as the rebound number, and this is correlated with the surface hardness of concrete. A higher R number means higher concrete hardness.
The rebound hammer can be placed in many configurations, including upwards, downwards, at any intermediate angle, and horizontal.
Inspectors should pay attention to the following considerations prior to conducting a rebound hammer test. The testing surface should be at least 150 millimeters in diameter. The surface should also always be smooth before testing. If there is any free moisture or water on the concrete surface, it must be removed. And finally, it's important not to test on frozen concrete, and concrete should only be tested after it has thawed, since frozen concrete tends to have high rebound numbers. Although the rebound hammer provides a quick, inexpensive means of checking the uniformity of concrete, the results can also be affected by the following parameters: smoothness of the test surface, size, shape, and rigidity of the specimens, age of test specimens, surface and internal moisture conditions of the concrete, type of coarse aggregate, type of cement, carbonation of the concrete surface, and type of mold. With recent advancement in sensor technology and development of wireless communication, a new generation of rebound hammers are commercially available. Recording and tracking job-specific details, including hammer angle and on-site verification of test results, was time-consuming and prone to errors. The new generation of hammers help engineers get around these issues. For example, new generation hammers apply real-time checks on the quality of datasets and do not need to be adjusted for the configuration of the hammer. In this video,
so as you are aware, there is a quality of the concrete can be obtained from this rebound number values, based on the rebound number values. So this all everybody knows that if less than 20 rebound number is poor concrete, and over 40 is a very good hardened concrete. There are two type of hammers we are using. One is the R value, which is normally used to mechanical, and Q value is used for the new generation tool. Q value is not affected by the orientation of the instrument. Okay, it tend to have the less depression than the traditional rebound hammer. Okay, the rebound hammer will get a different readings of Q value as well as R value. In this one, the original Smith hammer, which is giving the R value, and we can say that what is the comparison between silver Smith hammer, which is the latest one. Both methods involves impacting the surface and measuring the rebound. For original rebound, we measure the rebound distances mechanically in the original Smith. But silver Smith, we measure rebound velocity optically. The original Smith, we obtain R value, which correlate to the compressive strength, and Q value also correlate to the compressive strength. But what is the important here? The original Smith can measure conventional concrete strength 10 to 70 MPa, but silver Smith can be used in 5 to 100 MPa, increased lower and higher limits by 50%. Okay, so and we can see the correlation coefficient using the R value 0.84. The same thing when compared to the Q value hammer, so we are getting the correlation coefficient 0.97, which is more closer. The Q value is more effective based on the correlation coefficient. Okay, so typically we follow the IS standard, which is revised recently, IS 516 Part 5 and Section 1 2018, used for testing. We use this anvil for checking the rebound, hammer effectively working or not. Every 2000 impact we need to check once we record the readings. As given the known value, we need to verify. Okay. Generally, we can use the lowest 10th percentile curve is a conservative, using your own material and related to the structural member, so that we can able to predict the strength easily. Or coring, from the coring also we can do the better correlation, so that we can interpret the strength more accurately. What is the advantages? It is using the rebound hammer minimize the total number of cores, because taking a core always damage to the structures. And whatever the sample collected, it should be a representative so that we can get the correct reading. So extended quantitative information provided by small number of direct testing to the larger set of structural element, which can be done very quickly and non-destructively. That is the advantages. Okay, but based on the surface, the value may differ. The higher accuracy, if you want, you have to have the reference curves based on the coring you have to create, or the same concrete, we must have the correlation so that you can predict the with higher accuracy of the results. Now moving to the next one, the ultrasonic pulse velocity. Ultrasonic pulse velocity is an effective method for quality control of concrete material and detecting the damage in structural component. We use IS 516.5 section 1. Based on that, we measure the travel time of pulse of ultrasonic compressional stress waves over known path length. Okay, these UPV methods have been traditionally used for quality control material, mostly homogeneity of materials such as metal and weld connections. With a recent advancement in transducer technology, the test has been widely accepted in the testing of concrete materials. Okay, ultrasonic testing of concrete is an effective way to quality assessment and uniformity and crack depth estimation as per the new standard, which we are going to see the coming slides. Okay, what is the principle it works? The pulse velocity determined by the measuring transmission time from transducer to receiver, and the distance between the probes. That's velocity equal to distance and the time traveled. Based on that, we get the velocity. We calculate in a kilometer per second. This is the principle. It works. And what is the benefit? It can be used for detecting the voids, cracks, other internal imperfections or defects. If it is honeycombing or porosity, we can identify easily. Estimating the mechanical or structural parameters of material like porosity, strength, density, elastic modulus, we can able to calculate. Now there are the three different methods we use. The direct method, which is more reliable, semi-direct when direct is not possible, and surface, again there is direct, semi-direct is not possible, we do the surface probing. But what is important here, the least reliable, only the advanced users can do the proper interpretation, otherwise it's difficult. Because when you're doing the surface probing, we have to add plus 0.5 kilometer per second. Also temperature corrections we have to do when you're doing the testing more than 30 to 60 degree temperature. And how we can able to see the presence of defects increase in travel time? Always when the presence of honeycombs, the travel time increases here, in result in low velocity. Okay, if there is a crack, it taking a diversion and taking more time to receiving. When there is a crack through, it is not even passing through, it is returned back, there won't be any reading at all. So then you understand that there is a through crack and the pulse velocity is not passing through, or it's taking more time. So this is the interpretation you can have it from the ultrasonic pulse velocity. So as per new standard, above 4.4 kilometer per second is excellent, and 3.75 to 4.4 is a good, 3 to 3.5 is a doubtful category, below 3 is poor. Like given the picture here, this one under the 4.4 kilometer per second, it's a high quality concrete, higher pulse velocity. Second one, you can see the voids of the surface itself. Even inside also there must be a lot of voids or honeycombing. It's a very poor quality of concrete, lower pulse velocity. This is a below 3 kilometer per second. This is a good example of both. Where is the application? We assess the quality of assessment, voids detection, crack depth measurement, and estimating the material properties like density, elasticity, modulus, strength of the concrete. So applications we have seen how to measure the crack depth, etc. One is that when you see the crack, we use the crack scale to understand the width of the crack. But Whereas the crack depth used to be evaluated the overall structural integrity of the element. We need to understand the depth of the crack also. Okay, crack depth is when everybody want to know what is the depth, because the structural integrity is need to be evaluated based on the depth only, and it is help to understand the durability. The crack depth measurement can help repair contractor in evaluating the repair cost. What is the depth, how much we need to fill or grout or rectify. So we need to understand the depth and crack along with the crack depth width also. Okay, depend upon the nature of the project. So they want to use non-destructive techniques, non-intrusive techniques to estimate the crack depth. Okay, one way using the taking the core to understand from that what is the crack depth, but that is again destructive, because everybody want to know without damaging, without taking coring, to understand the crack depth measurement. Now this one you can able to see in this picture. From the crack we are having the probe equally this distance from B and 2 times B. Using this technique we can able to estimate transmit time at the distance B as well as 2B. So there's a formula given there, we can able to do it manually. Also I'm going to run the audio visual. There you can see that how it's calculated automatically, giving the values. You can able to see that.
For determining thickness of concrete, but also can be used for crack depth. Today we're just going to have a quick look at determining depth of crack in concrete.
Someone has to confirm whether it's okay. Yeah, audible.
Up here. Wait for it to boot.
Yes, sir, audible.
I'm going to hit measurement. Now there's a number of selections because we've selected crack there, so we're already in that mode. Here's the dimension B, which is 10 centimeters, 100 millimeters. That's how far we are either side of the crack, and twice that. So this is 100 millimeters, 200 millimeters, or 10 centimeters and 20 centimeters. There's our 10, 10, 10, 10, etc. So I'm just going to put some coupling on the ground in line with this. Just a bit of coupling, and a bit of coupling at those spacings. Now I need to make the first measurement here. I'm going to put the 2 transducers, one transducer there, one transducer here. They're not actually on the tape, they're just next to the tape. So first I'm going to hit play. I can see here, this is auto mode where it automatically jumps and automatically finds it, etc. Now I'm going to just move that because I can see quite clearly that the signal is actually received. It's actually there. So I'm going to select that. Now, next thing I'm going to do now, I'm going to jump to the second set of measurements. So I'll move my two transducers there, one here and one there. Now, we now hit this play button again. Now, this isn't jumping. Well, sorry, hang on. I just hit something by accident there. I've need to go back out. I hit zoom in, hit that plus button. So I'm going to set it back to auto mode. Now, it's jumped to that spot, but I can see quite clearly that the nice clean sine wave starts a little bit earlier than that. So I'm going to move it back, and I can actually see the sine wave is really just starting there. I can see that pretty clearly. So now I hit finish on that, and it's got a crack depth of 44 millimeters. So it's that simple, that quick to find your depth of cracks in concrete. Nice little instrument. Thank you very much.
So I hope that you understood now. When the T1, T2, when you're having the values in a microsecond, we can get the depth in a millimeter. So it's a very simple. We give the values and automatically it picks up and calculating and giving the crack depth. So normally the crack depths are not typically uniform like a straight line throughout the length of the crack. It's always shows as a lot of undulations. Sometimes it will be shallow, sometimes deep, and sometimes again coming back a different pattern. So how to determine? We need to different point we should measure the crack, and we can take the average so that we will have the average crack depth on the particular crack. Okay, so we have to take few measurements and then take the average. Now in this one, there are 3 cracks, C1, C2, C3. Then we have got the depth, 2.11 mm, 1.12 mm, 1.52 mm. So we know that what is the depth of the crack. Okay. Second one, there is a cover meter, we call it perfometer. It is based on the eddy current principle. It measures the concrete cover, also detect the rebar diameter and location. So nowadays we can able to see the scanning of rebar with the most accurate way. Within the 1% accurate you can able to see, or plus or minus 1 mm accuracy we can able to do that. This is one of the measurement they're taking at the site. There we can able to even there is no drawing is available, so we can able to map the reinforcement mapping, and we can create the drawings as well, and also understand the thickness of the rebar. It will give the accurate cover estimation of the rebar diameter. Now we can see that the limitations on this one, only the top layer can be get more accurately, because the congested areas means it won't separate it, what is the primary, what is the secondary. It will take it as a whole metal. So that's why that is the limitations in this cover meter method. See, bore size to be known plus or minus 1 mm bore size, and search it to be keep it in a properly directly over the rebar, aligned to the parallel to the board. It is not close to the neighboring parallel to the board, and not over to the near transverse bar. That will also give misleading results. Like in this figure, we can say that if it is keep it, this is the first one, it's a parallel and over the rebar. It may give the signal or the beep noise to make it correct. Other things are not at all correct, because we are not doing it correct positioning of the cover meter end on the rebar, so that we won't get the correct readings on this. Because here adjacent bar is connected, definitely it is not going to get the proper dia of the particular bar. So we have to move it further. Next one is one of the method to understand the corrosion is the basic test is the carbonation. So how the pH is reduced below than the 12, and the carbon dioxide react with the calcium hydroxide, then the corrosion starts. When the pH is drops below 8.5, the positive ion oxide film breaks down and rapid corrosion occurs in the presence of moisture and oxygen. So that's why when the crack is happen, easily the moisture and oxygen can enter to the structural member, reach the reinforcement, so that corrosion is happening. And we can measure the carbonation to understand the corrosion process, whether it's going to affect immediately, or it is reached to the level of the reinforcement, or there is a time to reach. To understanding the carbonation will help. So this is one of the tests happened at the site. Now you can see that the phenolphthalein spray on the freshly taken coat, there is a from surface, we can see there is a carbonation depth where the color has got changed from the pink to the original color. This area is we can say is a carbonated concrete. We have to take the few measurement and make the average, because the uniformity won't be there. That's we need to do that. Whatever the pink color is a uncarbonated concrete. Okay. So these are the minor carbonation. There is not much, only very few mm from the surface we can able to see. The other one, we can say the carbonation is much higher, but still, if you say it may not be a more than 10 to 15 mm, understanding this core. So if it is reaches to the cover only, we are going to start with the problem of corrosion taking place. Okay, let us discuss about the next one, the corrosion. Reinforcement corrosion, it's happening severely when it's in the marine environment, like what is shown in the picture. We are going to measure the corrosion using the GP500 instrument, which is shown on the left-hand side. This gives the optional potential and the resistance measurement for finding the probability of corrosion. This technique called Gaulow pulse measurement, finding the corrosion rate. See, here you can see that the electrode, which is having a silver chloride electrode, and connected to the reinforcement other end, and there is a handheld computer, which is the part of the GP5000 is used here to measure those informations. So let's get into the detail. To measuring the corrosion rate or offshore potential of reinforcement embedded in the concrete, we use this Gaulow pulse instrument. Gaulow pulse measurement technique is a fast polarization technique for determining the actual corrosion rate at the time of testing, because it can able to give the real-time readings. This instrument looks like that. One is handheld computer, and another is a Gauge we call it. This Gauge used to probe on the surface of the structures. But of course, we need to connect one end to the structural member where we have to get expose the reinforcement. We should connect it, and there will be a millivolt passed through, and the current is measured through the Gauge. This is the principle I explained to you. Okay. So this developers can measure the current and resistivity by calculating the galvanostatic pulse measurement. When galvanostatic pulse measurement are performed, the optional potential and corrosion rate and the resistance, ohmic resistance, can be determined all in one operation. The beauty of the instrument is we can get all the three information at once. You don't need to measure separately. We can get it at once. Basically, the Gaulow pulse can tell you how much corrosion you have now in the structures and what is the potential corrosion in the future. We can able to understand both. What is the use of Gaulow pulse? Why use a Gaulow pulse? Determine the corrosion rate, measure the offset potential, predict the lifetime of the structure. That is the main purpose we use Gaulow pulse. When you're talking about the structures, we are not using this instrument for a general building. We use the building highly important, like a nuclear power plant and some of the important structures. I have used a couple of places, nuclear power plant and the nuclear fuel complex, where the deterioration is very severe because of the reactivity. So we assessed the 4 buildings. Out of the 4, 2 buildings we recommended for repair and rehabilitation, and 2 buildings we said there is no point of repair. We should go for a rebuild, demolish and rebuild. So that kind of prediction can be made using this Gaulow pulse, because we know that what is the life is remaining, residual life of the structures. Based on that, our recommendation can be very clear and precious. Okay, proactively extend your structure's lifespan. If you're knowing that the structure is going to be stand up next 20 years, so we can plan for a proper maintenance now only, so that we can extend the lifespan of the structures. Okay, and it's providing the data to show that the product is decreasing rate of corrosion compared to the control. We have to measure in a different frequent times. Okay, if you are measuring 2020, we can measure after 2 years, 2023. For example, you can able to give the rate. What was that in 20? What is in 2023? So we can see what is the marginal increase or rapid increase, and how the corrosion is happening, the post activity of the corrosion of the steel, whether we are given any protection to delay the corrosion process. So we can able to control the rate of corrosion. We cannot avoid anyway, we can decrease the rate of control. And corrosion rate, when you estimate, there is a table given here. Using this, you can able to predict the lifetime prediction of the concrete can be made. So based on the this corrosion rate, what is the micro ampere per centimeter square, and what is the micro milli per year, we can able to estimate, and what is the corrosion level, and what is the time. If it is less than 0.5 micro ampere per centimeter square, it can be less than 5 year per micro milli per year. If corrosion rate is going to happen, it's a positive. The time is not applicable. But if it is increasing 0.5 to 5, then we can see the corrosion rate micro milli per year is 5.8 to 58. It's the corrosion level is low. It's more than 30 years. The 5 to 15, 58 years to 174 micro millimeter per year. This is a moderate. It's a 3 to 10 years. Then, if it is over 15 years, It's a more than 174 micromilli per year corrosion rate. It's very high. It's a less than 2 years. We can able to use this information to predict the service life of the structures. As he said that the polarized resistance technique used to measuring optional potential resistivity and polarized resistance. Okay. This polarization, there is a formula. It's given that the linear relation between the changes in voltage, which is the unit area electrode, which is given I core, is the corrosion rate equal to the voltage, the constant voltage, 20 millivolt we are giving here, and divided by the polarization resistance RP. We can able to calculate the I core value. So we have to apply this current 10 seconds only, we can get the result. And the monitoring the potential change of working electrode, which is based on the principle of silver chloride principles, which is more accurate than copper sulfate. Okay. From the recorded voltage history, we can evaluate the polarized resistance RP value. For that, we use the God rings. God rings can be used for different what you call the Greek pattern. We can measure the rate of corrosion. So for understanding the corrosion rate, Stern-Gary corrosion rate relationship used, which was I was telling I core equal to B by RP, resistance polarization. Okay. Then for distillate transit, I core to uniform metal loss, 1 microampere centimeter square equal to 0.012 micromillimeter per year. So based on this, we can able to predict the residual life of the structures, life of the buildings. When we get the readings, we can able to connect to the software which is provided along with the instrument. We can able to give the map created by the automatic through the software. We can able to understand the contour map shows that where the corrosion is higher, the red portion, orange portion is the higher corrosion, and the darker portion, the blue, is a lower corrosion, micromilli per year. Similarly, based on the optional potential, we can predict the probability of corrosion. Okay. Then resistant, ohmic resistance. So resistance measured in ohms, you know that. So in kilo ohms, we can having the reading. The same thing again. What is the severity? What is the mild? And what is the less probability? So we can able to understand through this contour map very easily. Interpretation will be much easier. So what is the application? It's use it for service life estimation and also evaluating the efficiency of corrosion, arresting the measures such as applicable of corrosion inhibitor or membranes or electrochemical removal of chlorides. This also used condition survey of suspect RC members. Monitoring corrosion activity in RC structures. We can monitor, like I said, that we can measure in 2020. After a few years, we can measure so that we can be able to understand what is the increase in the rate of corrosion. Measuring corrosion activity in the repaired areas. Once after repair, we can say that whether the corrosion activity is prevented or it is having the same. So we can able to monitor this. There is a ASTM C876 given the how to evaluation of corrosion activity. The again silver chloride. So this reading already we have seen that. If it is higher than minus 104 millivolt, this means only 10% of the probability of corrosion risk. This is called low corrosion. If it is less than minus 404 millivolt, is a severe corrosion. So 90% probability, 50% probability, there is a indicative readings are given there. Based on that, we can interpret your corrosion activity. And the kilo ohms centimeter is given that high corrosion probability, 10 to 20, medium corrosion probability is more than that, very small corrosion probability, but it's not affected too much. This also interpretation we can do from the resistivity of the particular member when we are measuring. Now let us move to the next one, interesting one. This infrared thermography, what I am going to discuss about. What it's happened, it's turned into the invisible light converted into the thermal image. So what is invisible light? It is a non-contact temperature measurement. It can detect the delamination of structure and moisture movement inspections and the energy loss in buildings. So we can use this technique, we can identify. See, what is the basic principle? Our eyes are not supposed to be able to see infrared light because infrared light waves are larger than the waves in the visible spectrum. Here we are given the electromagnetic spectrum. This infrared image, it sees the heat, not the light. It can capture the heat, absorbing the emissivity and displaying as a picture. So how it is that we are going to see that? Generally, thermal imaging, 8 to 12 micrometer is measured. And rest of the things, like you can see that there is a gamma rays and X-rays, ultraviolet rays, and whatever visible to sunlight, visible to eyes, human eye, we can see. But what we cannot see, infrared thermal, we cannot see. Microwave, you cannot see. Radio waves, short waves, medium waves, we cannot see. Okay, so this is the principle of that infrared is working. Now, if you see that in a better way, the gamma rays, X-rays, ultraviolet rays, the visible light, this all fine. But infrared, which is not visible for human rays, can be captured and displayed in this instrument, which is infrared rays. The radio waves, of course, we cannot see. It was, the what is infrared? Those who are not having a clue. So this infrared was discovered by the way back 1800 by astronomer Sir Frederick William Herschel. What he said, he measured the infrared radiation. What he did, after noticing this infrared is emitting the energy, he decided to measure the temperature just beyond the red portion of the spectrum. You all know web gear, this, what is the rainbow, we can say, different colors. But each rainbow has got a different temperature that was measured by the Herschel. Beyond the red spectrum, there was no sunlight, but it was temperature is measured by the temperature. That was here done. To his surprise, he found the region that had highest temperature of all. Even though there is no light visible, he can measure the temperature. That is the infrared. So, like nowadays, you can see that particularly in the public places, airport and railway station, they monitor temperature monitoring, not the COVID monitoring. COVID-19, they cannot monitor because this instrument gives the temperature only. Based on the temperature, they're screening the who is having the higher temperature. That's all. It's not a test for a COVID. If anybody is having a misconception, I repeat once again, this instrument is detect the temperature. Those who are having a more than the higher temperature, like 99, 100 Fahrenheit, they'll say that these people are having a fever. That's all they can say. After the fever, if the fever is related to what, whether because of the COVID-19 or any other related alignment, they will check it separately. So is a rapid screening. They can be use this tool within a fraction of a second. They can measure the body temperature. So like you can see, that's also used in the security. You can able to scan the whole body. Is they hidden anything, any metal or any other? They can able to scan. Not only the temperature, it's also security point of view. Now you understand the principle. Now this application used in the building diagnosis to understanding the leakages. When the above floor is leaking, we can able to identify. Normally in the normal eye, we cannot able to see except a few places. But this can identify where the moisture intensity and how is the moisture moving one place to other. We can able to understand. That is the technique we are using our building diagnosis. Now this is one of the roof here. If you see the normal, we don't see much problem here. But if you see the thermal image or scanning, we can able to understand there is a damage from the surface, and particular area is having some problem, so that we can pinpoint the source and we rectify easily. Without knowing that, we will be attempting to end up to doing the every place trial and error basis. Now there is an interesting case study I would like to share with you. This was a couple of years back. I did it myself so that I can explain in a better way. This is a swimming pool between the two towers. It's on the 13th floor. You can able to see overview picture. Now this was a newly constructed. Even after a few months, the water started leaking. So it is dripping from this pool exactly to the ground. There is even single drop falling in a big noise. So people are stopped moving in. The builder has got a severe problem. What to do? They tried with available techniques and all. Finally, he invited me to identify this. I spent 2 to 3 days time to do all the exercise. You can see the close-up view. There is a water is falling from this corner. There is even the false ceiling got opened up. The deck is there, so I can explain to you. Now you can see the close view. The water is dripping continuously. Nobody able to understand and rectify. They have got a real problem. The building is not selling. So it is a one apartment, for you give you an idea, it's a 5 to 6 crores. So they are not able to sell it because of this leakage. So here we can see that there is a trap door, only the entry. For me, it's a difficult to enter all the time to go underneath to do the investigation. There is no space even. I can show you that this is a space between less than a meter. So we have to go under this and see where is the leakage. We cannot see anything because there is a deck. Only leakages we can see from the edges. Then how to know that where the water is leaking? That's why these people, what the contractor did, they keep on injecting grout on the edges, but nothing is useful. You can see that a lot of cementitious material flowing and dried out. So finally, without damaging, we need to identify. That is a task. So we have analyzed all the things. We emptied the pool, and we understood what we also gone through that. How was the construction made? This was the RCC. After that, they're having a treatment of filling of voids and cracks. Finally, they are spraying the waterproofing system, and after that, they are providing the textile, then reinforcement mesh and shot treating. So they've done a several layer of the waterproofing method. See the short fittings being done. After that, they kept ponded more than 3 weeks. There was no single point leakage was observed. Then they finish it up with the China mosaic. Now this look, as I empty the pool, I can able to suspect all the inlet and outlet point, where even the plumbing line, everything. There was nothing much I can able to see. Then we had been going under that and checking. Finally, we do the scanning through help of thermal scanning. We identify, see like that, what are the spots, where is the moisture is concentrated, and we can see the outlets, and we can able to make it out. There is one of the outlet, it's leaking because of the porosity, and the joints is not proper. So we able to identify under the deck there was a leakage source. From there, water is going there, and swimming pool getting lowered because of this particular leakage point. So we identified that, and they can able to rectify clearly. For that, we need to spend at least 2 to 3 days to understand. It's not easy to see that where this leaking is happening. Okay. So then finally we give the recommendation how to repair, what kind of material to be used, and after repairing, we do the water ponding test. 1/3 of the height of the swimming pool filled with the 48 hours to check the water tightness. Then again we fill it further 2/3. We checked it. Then we ensure that now there is no leakage. That was the procedure adopted. This is after completion of the job. Okay, the client was very happy when the problem got sorted out, because it was a very serious problem for him. Okay, this was the one of the case study. And now next one, I will be talking about another non-destructive test method, which is quite interesting one. Is there time for me? Hello.
Sir, continue.
Yeah, fine. Just I'm going to talk about one of the important non-destructive testing, in-place strength, understanding the in-situ strength without taking a core, without testing a core. So you can able to see that the core destruction always it's a destructive test. Not only it damages the concrete integrity, it might affect the reinforcement bar in RC structures. So we need to find out what is the better way to avoid coring. Coring is always damaging the reinforcement, knowingly or unknowingly. When you take the core again, you drill the core, you take it to the lab, you make it parallel and cure for 48 hours, then you crush it. This whole process taking more than a week to get to know the strength of the particular member. So whereas when you're doing the cut and pull out test, just you need to 25 minutes. You can get the strength then and there. You don't need to wait for 1 week. Okay, this is the advantage and the minimal damage to the structures without damaging reinforcement. Now, how it's operate? What is the benefit? Let us see quickly. This one you can able to perform wherever you want to do that. For that, drilling core definitely is a higher cost because more number of core damage the structures, and we can use the rebound number and penetration test, ultrasonic pulse. This required a lot of correlation to give the more accurate result. If correlation is not correct, you can interpret wrongly. Pull-out test, it's a give the reliable estimation of the strength. So as per ASTM C900, we can perform this test, pull-out strength. That's called cut and pull-out. We call it CAPO. It does not require a pre-planning test location. Wherever you want, you can do that. Can perform test any accessible location because we have to drill a hole and do the things. We need to be accessible reasonably. So this permit testing of existing structures, immediate result compared with the core results, so that you can ascertain the values are accurate. Now, how to prepare the test location? Now we can see there is a drill hole, 18 mm drill hole. We can able to drill up to 70 mm length. There is a special cut for inserting the ring. That is the specialty of this particular drill. So this is a side preparation done with a diamond bit. Once the preparation done, you can see the smooth surface. There we can apply the test how it works here. The ring get rotated. So this is a coil ring near to the cone. We are fixed inside, and the cone is like that. The ring is an expandable ring. We place it here. Okay, and when you pull out the ring, we can get the damage of this V cone type damage happens. So let us see. Just I can run a video. I think there is no voice here. You can just observe how the test is performed at the field. Generally, this test can be performed at a retain wall or water tanks, silos, etc. Because taking a core, it's damaging the structure again. Once you damage, very difficult to repair. Only we can fill the concrete, but we cannot substitute the reinforcement what we got damaged. So the rate of loading is very important. You have to give the uniformly. We cannot do force. Yeah. Now you can see that damage portion. Yeah. What is the value we have got it? 38.4 in a kilonewton. It's a float force. We can able to estimate the compressive strength based on the force what you have received. Let me tell you. Now you can see there is a portion of the cone. This only damaged. The ring is here. The ring got expanded. We got the broken from the surface. This gives the actual strength. There is a curve plotted. For the cylinder is a red curve, and the blue line for the cube correlation. Whatever the pull-out load in kilonewton is directly we can relate to the compressive strength in the megapascal. Okay. Now, how I can say this is a table also given there in case any difficulties for accurate measurement, we can follow this table to get the actual compressive strength. Okay. Now, for example, if you are having a 28 kilonewton, the 28.1 is the actual force as per the calibration. So 36.7 is the cube strength we can able to interpret. Now we have done for to understanding this correlation. We have done. We have seen that there is a capo result in the orange, and the brown is the cube result. Is more or less is a comparative. This is one of the tests we have conducted with the IIT Delhi. Okay, and the second one I have done myself. We have taken the capo, and the next location itself we have taken the core. So I have crushed the core and got the strength, so that it's all closely matching except one. There is a deviation. Maybe the concrete is also is having a 50% variations in the strength. It's acceptable. But of course, when you're leaving the one strength deviations, the most of them are perfectly matching. And a similar way, the cube, directly we costed a cube. One cube we did a capo test, another one we crushed it as a conventional way. That's all very close. This all the readings I can correlate it less than a 6% variations is achieved. But even though the 8% variation is acceptable for the international standard. Okay. So pull-out test offers the possibility of estimating in place concrete with acceptable reliability of the strength. Okay, the stress and the state created by reaction, the ring leads to the compression state that explains the good correlation with the compressive strength. The capo test allows testing without pre-placing insert. You don't need to do anything. Wherever you want to say, you avoid the reinforcement, you drill a hole and do the capo test easily. Okay, this is a more effectively. We have been using a lot of, including the housing segment also, because there is a lean members nowadays they are using it, but they don't want to get it damaged by taking a core. Most of the housing societies in Bombay, they prepare instead of the cut and pull out test. Of course, we use a lot of things in the industrial segment, but housing segment also prepared to have this test. Okay, now I'm coming to the conclusion. Yeah. Taking a few seconds. Yeah, having said that, we have seen the assessment, what is the requirement for the assessment, and different non-destructive testing. And if you want to know the mechanical properties of the element or the concrete, so if you want to know the compressive strength of the in situ, we can do core test or rebound hammer test, pull-out test, or rinse probe test. This all the tests can be chosen. The quality of concrete, if you want to know, ultrasonic pulse velocity, you can understand the uniformity of the concrete. Tensile strength means you can have the pull-up test and split tensile strength. The bond test, we generally use for the repaired surface. The pull-up test will be much useful. We can choose from those non-destructive tests. If you want to know the chemical properties, electrochemical activity, we can able to conduct offshore potential, electrical resistivity, rate of corrosion by using pulse in one go. And carbonation depth. Generally, we use the trampoline test. We spray the trampoline, as is shown in the picture. Use the spectroscopy and infrared spectroscopy to understand the carbonation and alkali aggregate reactions. For that, we can conduct petrography examination. If you want to know the chloride content, we use the chemical analytical method. So we can choose these methods to get the informations. How to correlate the result? For example, I'll tell you, if you want to know the corrosion activity, risk of corrosion, we can see what is the cover thickness required and the quality of the concrete. Relatively, if the cover thickness is good and the quality is good, then we can say relatively it's not a corrosion prone area. If the cover thickness is there but bad quality of concrete, that means there is possibility of corrosion because of porosity, the hazardous substance or moisture might have entered to the structure, the corrosion might be possible. So this might be the corrosion prone zone. Less cover and good quality concrete. In this case, also is the main parameter affecting the durability of the structures. So this can be interpreted like that. The conclusion. The durability monitoring, the NDT tests are used for easily to monitor the quality of distress or durability of the concrete structures. We can choose what is the test required. All the non-destructive testing instruments have proved to be reliable and invaluable nowadays. It's giving more accurate information. Doing the interpretation of the test is required a competent person to arrive at acceptable evaluation of the concrete regarding its quality and strength. And diagnosis of defects and condition assessment are essential prerequisites for the successful concrete repairs. Diagnosis, if you start repairing, that means without going to a doctor, you are doing a medication of it. It may be successful sometimes, unsuccessful many times. Point, I'm end of this place, repair in place. Understood? It's relevant to today's topic. Thank you. Thank you for the listeners. If there is any questions, yes, to answer your queries now. Over to you, organize.
Yeah, thank you, Gopal Krishnan. What we'll do is that questions, the typed questions, will mail it to you, and the participants can put the questions. And send it to our Gmail, in our email ID, and the same questions will be passed on to Gopal Krishnan for answering the question.
Yes, you can write to me at the email ID is displayed and my contact number is displayed. You can even chat with a WhatsApp chat, no problem. I would love to answer in this platform. Maybe one or two questions we can take, if anything specific.
Yeah. You can. Aishwarya, just see any questions. Aishwarya.
Yes, sir. So there is only one question asked during the session by Mrs. Jayanti. Any NDT techniques available for testing the substructure and underwater structures?
Yeah, the same thing what I explained to the galvastic pulse, which is a G1000. I have shown the God ring. This what we are using the above structures. Substructures we can use the same equipment with this different probe, which is the what not we can use that. Maybe we can use the computer outside of the surface. We can take it to the underwater. We can measure the corrosion activity. That is the one. And relatively other tests. Carry out the repair, underwater repair. That is not very largely used in our country. In other countries, they are practicing many underwater repairs, special products being developed and using successfully. But in our country, still we are at a very early stage, I can say. There are few NDT tests, including like follow or understanding the corrosion can be used on, and the rest of the things I'm still not able to comment on this.
Okay, we'll conclude, sir. We'll conclude it. We'll conclude.
Yeah, please.
Yes, sir. Good afternoon, friends. We have come to end of another interesting and relevant topic, non-destructive evaluation of reinforced concrete structures. I thank Engineer Gopal Krishnan for delivering a lively and vibrant talk on the topic. He had kept the audience glued to the webinar. Thank you, sir, for sharing your experience and the latest technology for non-destructive testing, actually, which we were also that pull-out test and all that was a new new experience for even for me also. We are listening for the first time. Thank you very much, sir. I thank all the participants who had spared valuable time to attend QCrete webinar series. Actually,
thank you for
yes, sir. I'm Shelly Fernandez. Signing off till we meet
Thank you very
again
much
next Saturday to join you all with a new topic and new technical expert for the talk. Thank you very much. Thank you, sir.
Thank you. Thank you.